question here is asking us to determine the tension in the cables BA and BC. So we have to determine the force acting on BA and BC to support the 60 kilogram cylinder in this figure in here. So this cylinder is 60 kilogram. We convert that into newtons by multiplying it by 9.81. Therefore, the first thing we have to do is to determine our sign convention. So for our sign convention in this case, so sign convention. For our sign convention, we will take in this direction to be positive for x, y axis, and if we're dealing with moment, we will take anti-clockwise to be positive. In our solutions, we will after the sign convention, then we have to do the free body diagram. On the free body diagram, we know that the force is acting or the force is acting on we know that the force is acting on B, or this B should be, or this not here, or it should be in equilibrium. For B to be in equilibrium, so B will be at the origin of our drawings. So in the free body diagram, we will take B to be at our origins. So downwards on the negative y-axis, it's D, which is 588.6 Newton. Also, we have on this direction, we have C. This C acting at 45 degrees from the positive x-axis. We also have A acting at 3, 4, 5 similar triangle or special triangle. Now we did our free body diagram. After free body diagram, we are applying the equations of equilibrium. So equations of equilibrium. Equation of equilibriums, the sum of all of the forces should equal to 0. Sum of the forces on the x-axis or the x direction should equal to 0. Let's find the forces acting on the x direction. For the first one here, so the component on the x-axis for FBC, for this vector here, FBC, or this force in here, will be FBC cos 45. So FBC cos 45. And on the negative x-axis, we have this force in here, and we got 4/5 FBA. So minus 4/5 FBA. And downwards, we don't have any x component, therefore that all should equal to 0. From here, we can say that FBC, this one in here, we know that also cos 45 is equal to 0.707 FBC, and this will go to the other side, which equal to 0.8, 4/5, it's 0.8 FBA. FBC equal 0.8 divided by 0.707 FBA. FBC equal to, when you divide these two together, will be 1.13 FBA, and let's name this equation here to be number 1. Secondly, now we are going to get all of the forces, some of the forces acting in the y direction, and they all should equal to 0. For the first force in here, BC, we have here FBC sine 45. So FBC sine 45, and on the other side here plus 3/5 FBA, and downwards we have negative 588.6 Newton. That all these all should equal to 0. Solving for this, we know that will be 0.707 FBC plus 3 over 5, it's 0.6 FBA. They all equal to 588.6 Newton. And from here we can name this equation in here, we can name it number 2. Now we can substitute FBC here, 1 into 2, so sub 1 into 2. So when we substitute FBC here, so we know that we have 0.707 FBC itself equal to 1.13 FBA plus 0.6 FBA equal to 588.6 Newton. From here, when you multiply these two together, that should equal to 0.7989 FBA plus 0.6 FBA equal to 588.6 Newton. Adding these two together, that will be 1.3989 FBA equal to 588.6 Newton. Solving for FBA equal to 588.6 Newton divided by 1.13, so that's 1.3989, and this all should equal to, when you divide these two together, that should equal to 420.8 Newton. Now we found FBA. We can, let's name this equation here or number it as number 3. So now we can substitute 3 into 1, so sub 3 into 1. FBC from 1, FBC equal to 1.13 multiplied by 420.8 Newton. This all should equal to 475.5 Newton.